Hello, 8th grade. Please have your books open to page 298. We're going to go through solving equations with both variables on both sides, excuse me. So what we've already seen so far in our last assignment was we had, for example, we may have had, 8b plus 2b is equal to 10. And this is a nice simple problem just to use as an example. And on one side of the equal sign, we had 8b's and we also had 2b's. We're adding them together. So if I had a total of 8b's here and 2b's here, if I add those together, I have a total of 10b's equals 10. And so then I asked myself, 10 times what is equal to 10? Obviously that would be 1. But if I didn't know that, I could show that by dividing both sides by 10, leaving me with b on the left is equal to 10 divided by 10 is 1. And so there I have my solution to my equation. Now today, it's going to look a little bit more intimidating because what we have going on is we've got the variables on both sides of the equal sign. So what we're going to do is we're going to try to collect like terms on one side of the equal sign. I had a teacher in high school that would state, and this is just something that I heard many years ago, and it still has stuck with me today. And it's just an easy way of thinking about it, is that algebra is really easy. It's all about moving your letters to your left and your numbers to the right, and don't forget to switch your sign. We're not even going to talk about the switching of the sign part right now, but the letters to the left, that's really essentially what we're going to try to do. So in example 1, I'm given the problem x plus 2 is equal to 3x. And I said move your letters to your left and the numbers to the right. Don't forget to switch your sign. I might actually do it the other way around, actually put my letters to the right. And so what I mean by that is, and it kind of depends on what the layout of the problem is. In this case, I've got a bigger coefficient. The coefficient is the number that you're multiplying the variable by over here than I do over here. There's a coefficient on this one. It's really 1. It's kind of hidden there, but that's really 1 times x, which is the same thing as x. Okay? And I have a bigger coefficient over here, which is 3. And so because of that, I'm going to subtract x from both of these sides. So if I came in here and I took an x away from the left side of the equal sign, how many x's would be left? There wouldn't be any. I've just canceled it out. All that is left on the left side of the equal sign is this plus 2, or this positive 2. On the right side, if I started with 3 x's and I took 1 x away, I have now 2 x's, or 2 times x. Okay? So now what I have left in my equation is 2 is equal to 2 times x. So now I'm asking myself, 2 times what number is equal to 2? Obviously, we already have figured this out in our head. But again, if I wanted to show that, which it is always a good thing to show that, I'm going to show that by dividing both sides by 2, I should say. It cancels out on both sides, leaving me with 1 over 1. In other words, 1 is equal to 1x over 1, which is the same thing as x. So 1 is equal to my x. And I can go back and I can go to the very beginning and just double check to make sure that this works. So it's always good to check your work when doing algebra. So in place of x, I'm going to plug it in with 1. So here's 1 plus 2 is equal to 3 times 1. 1 plus 2 is 3. 3 times 1 is 3. And that checks out. That works. So 1 is equal to x. X is equal to 1. Really, I don't like the fact that your math book left it like this. I would prefer you to write your answers like this, letters on the left. So once you're done with it, you can just switch it over and say x is equal to 1. That's just kind of a little mathematical pet peeve of my own that I just wanted to share with you. Example 2, we're going to solve some more multi-step problems. In example 2, I'm reading in your book on page 299. You should be there. It says each side of a triangle has the same length. So they show you a triangle. It all has the same length. What's the perimeter of the triangle? So how am I supposed to figure out the perimeter of the triangle? Well, first of all, realize that the question is not, in this case, what is x? The question is, what's the perimeter of the triangle? The only way I'm going to be able to figure this out is by figuring out what x is. I don't know what x is. I don't know what the side length of the triangle is, but I do know that all three sides are the same, and one side is marked as 5x plus 9. Another side, which again, I'm told all sides are equal, the other side is marked as 7 times x plus 5. Okay? So now I have 5x plus 9, which is equal to 7x plus 5. Hey, I've got this equal sign tied in here. I might be able to do something with this. So again, I'm going to look at this. I'm going to say that there's 5x's over here. There's 7x's over here. I'm going to take away the 5x's on the left. And to balance out my equation, whatever I do to one side of the equal sign, I've got to do to the same to the other side. So I'm going to subtract 5x's over here. That cancels out, leaving me with no x's. On the left, it leaves me with 9, which is equal to, and then on the right side, we're going to get to the what it's equal to. 7x's minus 5x's, that's 2x's that are left. The plus 5 is still there. That was a interesting looking 5. And now I'm left with 9 is equal to 2x plus 5. Okay, so now what? Let's get rid of, remember what I've been saying, you want your letters on one side, you want your numbers on the other. So I'm going to get rid of I'm going to kind of do this reverse PEMDAS style. Instead of taking care of the multiplication, I'm going to take care of the addition and subtraction. That's the inverse way of doing it. Instead of a plus 5, I'm doing minus 5. And I'm going to do that to both sides. Again, this cancels out, leaving me with 2 x's on the right side. On the left side, I have 9 minus 5, which is equal to 4. All right, now I'm in business. Now I've got the problem. 4 is equal to 2 times the number. 2 times what number is equal to 4? Again, I know that you already know that the answer is 2. But let's actually just show the inverse operation. I'm going to divide both sides by 2 to undo this multiply by 2. And that gets rid of this. It leaves me with x. 4 divided by 2 is 2. Again, please, I'd rather you show your answer that way rather than the way before that. X is equal to 2. So there we have it. I've solved my problem. I got my answer. X is equal to 2. Well, yes, I did solve my for x. But that's not what the question was asking. The question is asking, what is the perimeter of the triangle? So now what I'm going to do, I know that my x is equal to 2. I am going to pick one of these two side lengths. It doesn't matter which one because they are both the same. I think just for my sake, I'm gonna pick the first one that we had, 5x plus 9. And I'm going to replace the x with 2. 5 times 2 is 10. 10 plus 9 is 19. Each side of my triangle is 19 units. But, again, I'm still not being asked how long is each side. What I really want to know is how long is it, or what's the perimeter of this whole triangle. So now the perimeter of a triangle is going to be side plus side plus side. Each side is exactly the same. I have 19 plus 19 plus 19, or I could call that 3 times 19. Either way, it's the same thing. 3 times 19 is, well, let's see here. 3 times 9 is 27. 3 times 10 is 30. 30 and 27. 57 units is my answer. My triangle is 57 units around. The perimeter of the triangle is 57 units. Okay? So that's kind of fun. I really like problems like this. I think it's fun when you go from variables on both sides. So again, you want to get the variables on the same side, or eliminate each other, simplify it however you want to say it. Then the constants are the numbers that don't have the variables. You're going to do the same thing with those guys. And in all of these steps, I mean, it is a lot of steps, but you know, doing that, you can problem solve your way through quite a bit and come up with the perimeter of a triangle, for example. In example 3, I really love the distributive property. Some people get scared by it, but it is a very, very powerful property. It's important to know your property, so please be familiar with it and practice it. So in example 3, I have the problem 21x, 21 times x equals 3 times the sum of 2x plus 30. There I have it. So again, a couple sheets back, what I want to do is I want to get my x's on the same side. But I can't really do that because I've got these grouping symbols in the way that say I'm supposed to do what's in the parentheses first. There's a way around that. It's the distributive property. The distributive property says that if I'm multiplying something by a sum or a difference, I can distribute that multiplication to both pieces of the that's in the parentheses. So it's going to be 3 times 2x. 3 times 2 is 6. X goes with it. So if I have 2 x's, and I'm going to have it 3 times, I've got 2 x's, I got 4 x's, I got 2 more x's, that's 6 x's. So 6x plus 3 times 30 is 90. And 21x goes down with it, okay? In this case, 21x is my larger coefficient. So I'm going to subtract the 6 x's from both sides. 21 minus 6, that's 15x. These guys cancel each other out. There's no more x's on the right. All I have is a positive 90 on the right. And last but not least, I'm going to divide, to do some inverse operations here. What's happening to my x? I'm multiplying x by 15. So to undo that multiply by 15, I'm going to divide both sides by 15. 15 divided by 15, I got x on the left is equal to 90 divided by 15. 90 divided by 15 is 6. X is equal to 6. And I can double check that. Again, always a valuable thing to check your work. 21x equals 3 times 2x plus 30. There we go. I'm going to substitute 6 in place of x. 21 times 6 is equal to 3 times 2 times 6 plus 30. 2 times 6 is 12 plus 30. 12 plus 30 is 42 times 3. And I'm going to bring this down then. 21 times 6. 6 times 1 is 6. 6 times 20 is 120. So it's 126 is equal to 3 times 2 is 6. 3 times 40 is 120, so it's 126 is equal to 126. It checks out. 6 is the value of my variable. Example 4, I've got another situation. This is just the same kind of thing. It's just going to be a word problem. So let's take a look at example 4. It's on page 300. It says that you pay $20 for a youth center membership. Drum lessons at the center cost $8 each for members and $12 each for non-members. You take 2 more lessons than your friend, a non-member. For what number of lessons will your friend pay the same total amount as you? I'm going to reread that. I'm sorry. You take 2 more lessons than your friend, a non-member. For what number of lessons will your friend pay the same amount as you? In other words, I want to take the same number of lessons as my friend. He's a non-member. I am a member. I want to know, when is it going to be that we're going to pay the same amount? Well, wouldn't we never pay the same amount? Well, you might think that, except for the fact that we have a membership fee that we have to pay up front. Okay? So what we're going to do is we're going to have our friend on one side. We're going to have me, or you, or whatever you want to say, on the other side. And I'm going to look at the price per lesson multiplied by the number of lessons. That's going to be equal to, I want this to be equal to my price per lesson times the number of lessons, and I want this number to be the same on both sides. But I also have to remember that I have to add my membership fee. And I'm just going to abbreviate that, mem fee. Okay? I've got to add my membership fee to this cost. So you might have been saying, well, your prices are going to be less, Mr. Lorenz, so it would never be the same, except for I also have this membership fee that he did not have to pay. So at some point, these two should be equal to each other. We're going to figure out when that is. And this is really nice because if you can do this with a lot of stuff, this kind of situation shows up quite a bit. You know, is it worth joining, in this case, like some sort of club or membership, or is it better to just buy the price per lesson? I mean, there's situations like this that happen all the time. If you are able to tie the two sides of it together and figure out when would it be advantageous for me to do this, that is a powerful tool. So let's see here. My friend, I know that my friend's price per lesson is $12. I know so because it says so in the book. And he's going to take a certain number of lessons. I don't know what number that is, so I'm going to use a variable, n. It's going to be the same n that I have over here, because n has got to be equal to the same thing throughout the whole problem here. My price per lesson is $8. I'm going to multiply that times n, but I also have that $20 fee that I had to pay at the beginning. You follow? I am just realizing that I actually took 2 more lessons, and I paid the same amount. So I take 2 more lessons. I just realized I misread a piece of the problem there. It says you take 2 more lessons than your friend, a non-member. For what number of lessons will your friend pay the same same total amount as you. So I'm going to get 2 more lessons out of this than he is. And I want to, so his number of lessons is going to be the same as mine plus 2. So that's how I have this set up. This is not necessarily a good format, math grammar, I guess I would say. So I'm going to rewrite this as 12n is equal to 8 times n plus 2 plus 20. Okay? Now I've got these parentheses here. I'm going to get rid of them using the distributive property. 8 times n is 8n. 8 times 2 is plus 16. And then this plus 20 just drops down. 12 times n is equal to 8n plus 16 plus 20. Well, guess what? This plus 16 plus 20, I don't need both of those. I'm going to combine those right away. 16 plus 20 is 36. And now I'm going to subtract 8n from both sides, and I'm going to pick a different color to do that, just because I want to. So I'm taking 8n's away from the right side. I'm going to take 8n's away from the left side. On the right side, I'm left with 36. These cancel out. 8n minus 8n is 0 n's. And 12 n's minus 8 n's is 4 n's. I'm running out of room here. I'm going to grab another sheet of paper. I'm just going to copy this down. 4n equals 36. So I can finish my problem. How many lessons will it be when I take 2 more than, will he take when we pay the same price? So 4 times what is equal to 36? I hope you already have figured that out. It's going to be 9. But let's just actually do the division here. I'm going to, or at least show the division. The 4's cancel out, leaving me with n is equal to 36 divided by 4, 9. 9 lessons. Your friend pays the same total amount as you, and he only gets 9 lessons instead of 11. All right. Hopefully this helps. Hopefully this makes a lot of sense. If you wanted to see any of these again, you can go back. You can certainly go back and look at this video again. Scroll back to certain one of the examples so you can see some examples like your homework. Speaking of your homework, I've got it right here, page 300. I want you to do numbers 2 through 10. Do number 15, 19, and 20, and then 33 is another word problem similar to the one that we just saw. Thank you very much. I hope this was helpful, and get to work and have fun.